Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 4. We talk about the sequence and the series. So this is the second video for the lecture number 23, how the representation of the functions as a power series. And for the first video, we talk about, how to, get the power series from the geometric series. So to represent the functions here, right? We manipulate the function and make it kind of match the geometric series. And then we will, use geometric series to create the power series. So the second video we're going to talk about is how do we do the take the differentiation or the integration of the power series. Okay, so let's go ahead and get a start in here. And so let's see here. All right, so for here, we'll continue with our second video. We're going to talk about the differentiation of and the integration of the power series here. Okay, so let's go ahead and let's try to get a start here. So let's say here, so we say if we have a functions here, so if we have f of x, it's a function as a power series, right? So n from 0 to infinity, and the cn x minus a to the nth power. And also we know this series, this function has the interval of convergence. Okay, with radius, so the radius convergence is r is greater than 0 here. Okay, so then we have a few good characteristics here. So the first ones here, we said f is continuous. If f is continuous from the a minus r and a plus r, right? So a is the centers here. So we know f is continuous because we can find the radius of convergences here. And then the second ones here, we say, okay, so if f of x is continuous, then we know for all the x, in this intervals here is a minus r and a plus r here, then we say we may be able to differentiate it here. So we say f may be differentiate by the terms. Okay, so we say, how do I take a look at the derivative of f prime x here, right? So the derivative of the f prime x really is you take the derivative of this power series here. So these ones will just be you summation, you take the derivative to the inside. So here you use the power rule, so you move the n down. So this is cn, and this is x minus a, and minus 1 here. And in here, we need to be careful. So here, our original series is start n equal to 0. But here, since I drop out 1n, so I cannot start at 0 anymore. We'll have the negative 1. So not the polynomial anymore. So we will say that n is 1 to infinity here. Okay, so that's why one thing we need to be careful is here. Then the other things we say, hey, if we want to integrate, we can integrate that. So we said for all the x's also in this the a minus r, a plus r's here, right? So we say f may be the integrated by the terms. So that means if I want to integrate, see here, if I want to integrate f of x dx, So what you can do, you can just integrate inside, you can just integrate the inside of these functions, right? So you will say here, this is n from 0 to infinity. So you have Cn, so integration will just be n plus 1, x minus 8, n plus 1 here, right? And then you can add a constant, just like we do the typical integrations here, okay? And so in here, that's what we says here, you can integrate the power series, you can take the derivative of the power series here. The only things we need to be very careful here. So we will say, both the derivative and the integration. Okay, so they both have the radius of the convergence here, R, is like the original functions, right? So they both have the radius of the convergence like the R as the original functions here, but be very careful. And then, but the end point is not, right? But the end point of the A minus R and A plus R must be checked. Just like we did for the power series, must be checked individually. Okay, so now in here, the reason why we want to introduce, we say, hey, for power series, we can take the derivative and we can take the integration. Because in our next video, we're going to say, how do I manipulate that geometric series again by using the integration or the derivative? Then we can find the power series here. Okay, so let's take a look at this ones here. So this problem is pretty easy. So let's say the f prime x, find the f prime x if the f of x is, is a power series. So this one will be easy. So we say f prime x, right, would just be you take the derivative of the whatever is inside. So 2n, n is a constant. Then you say the n, so it is x minus 1 to the n minus 1 here. And so the only thing we need to be careful is here, the original ends from the, the original n is from the zeros, right? So now, because I dropped 1, so I need to start at 1 to infinities, right? So it's pretty simple and straightforward. Okay, so now let's take a look at the problem number 6 here. So they said f of x, and I want to find the integration. So this is the same thing. So we said f of x dx will just be you integrate inside the summation sign. So it's n from 1 to infinity. So I have n factorial. And then here, this one's here, this is n plus 1s, right? And x minus 3 to the what? N plus 1 plus c here. All right. So now this one's here will be, okay, so you can say the c, move the c to the front or leave it behind, doesn't matter. So this is n equal to the infinity. Then n plus 1 times n factorial. What is the bottom here going to become to? N plus 1 to the factorial. And this is x minus 3, the n plus 1. Okay. All right, so that is pretty straightforward and pretty easy. Okay, so now let's take a look at problem number 7 here. So the number 7, let's say, hey, is the f of x equal to the xn is continuous at the x equal to 2 here. All right, so how do I do that? So the first thing I said, okay, I need to find what is the, if it's continuous, right? So I need to know where is my domains here, right? So that's why I need to use we call this the ratio test. So this one here is an, so this will be x to the n plus 1, then for the n plus 1 over an, so it's xn and 4 to the n's, right? So this is the limit n approach to infinity. So this is 4 the n plus 1, and the absolute value of the n plus 1, you flip, so this is absolute value of the n and the 4n. Then you cancel, so you will get this is the limit n approach to infinity. So you will have the absolute value of the x, right? So the absolute value of the x and your 4n will cancel. So here, so this will be less than what? It's less than 1. So the limit is existing or not existing, doesn't matter because the n's cancel out, right? So that's why I would say that this is the absolute value of x over 4 less than 1. So I know the x is less than 4. So x is from 4 to what? The negative 4. And since x, right, so x equal to 2 is inside this radius of convergence here, right? So because of the, it's inside the interval, it's inside this interval of convergence. So I know the f of x is what? So I know the f of x is continuous at x equal to 2. Okay. All right, so this video is a very short video. We talk about is how to take the derivative, how to take the integration. The only thing we need to be careful is when you take the derivative, and then where is your number of the n star need to be pay a special attention here, right? So you need to drop off, because I drop off the n's here, so you need to start at 1. Okay, so this will be a very short video, and we do need this one for our next topic is how do I use the integration and the derivative then to find the power series by manipulate type of the the geometric series. We know how to find the power series from the geometrics here. All right, that's it. All right, so let's talk about the next one in our next videos. Okay, bye. Have a good day here. All right.